Hi guys, thanks for joining again. So this is another lesson on SUAT. So this time we will discuss vertical motion, which is basically when objects are traveling up and down. So just a quick reminder, make sure you're making notes as you go along, and please do attempt the worksheet in the description. Uh, Practice in mechanics is more important than any other module. So make sure you are practicing the questions that I set. So let's make a quick start. Right, so vertical motion, as I said, is objects moving up and down. Okay. Now, when an object is in the air and it's not attached to anything, no string, no other support, it's in the air on its own, there will always be one force acting on it, which is gravity. Okay. Now, gravity, for the Cambridge syllabus, we will take as 10. If you are doing Pearson, you can take 9.8, depending on whatever exam board you're doing. Because this is specifically for Cambridge, we will take gravity as 10 ms. Okay. Now, gravity is your acceleration when we model for SUAT. Right now, we all know that gravity always acts downwards. Right, it's always putting pressure on the object to go down. Okay. Now, if your positive direction for the whole question is upwards, then obviously gravity or acceleration would be negative because it's going in the opposite direction, which is down. Okay. If your positive direction for the whole question is down, then your acceleration will be positive 10. That's because same direction, gravity is down, as is your positive direction, right? We'll discuss that more in depth when we do a few more questions. Now, with SUAT questions based on vertical motion, we have to be very, very careful with regards to the vocabulary used in the question. Okay. Now, there are times when they will use phrases such as, a ball is projected or thrown. And sometimes they will say a ball is released or it falls or it's dropped. Now, both of these are very, very different things. Okay. When we say projected or thrown, what we're saying is what the moment the object starts in motion, there's a force being applied, which forces it to travel at a speed. Okay? Because when we throw something, we apply a pressure to it. Or if we throw something down, then we are applying a force to it, which allows it to start off with a certain speed. Okay, so because projected or thrown or any other similar word means it's starting off with a motion, it's starting off with a force, there will always be a initial speed attached to it. Right, so if the question says projected or thrown, there will always be an initial speed. They might give it to you in the question, or you might have to calculate it. Okay, so we will just model it as question mark. There is an initial speed, but we don't know what it is. Okay, the second scenario is where an object is released or it's dropped. Okay, what that means is you basically hold it in the air, okay, and then you just leave it. Okay, so in this case, you are not applying any pressure or any force at the start. You are simply letting it go from its position, right? In this case, there's no initial speed. There is no starting speed at all, because all you've done is you've let it go from where it was. You've just released it. Okay, so in this case, your initial speed, which is u, would be 0, because you're not applying a throwing force or a projection. All you're doing is releasing it in the air, right? So they can say an object is released or an object falls or an object is dropped. Okay? In all of these cases, u would be 0. The initial speed is 0 because we are not applying any starting force to it. So these vocabulary are really, really important. There will be more important words and questions which I will show you as we go along, but these are very important to know. Right, so moving on. A few other key things you need to know for vertical motion. Now, if you think about what happens if you were to throw anything in the air, right, from the ground or with your hand. Let's say you throw a ball in the air. Okay, if you throw a ball in the air, after a while, it will come back to the ground because there's gravity acting on it. Right? Now, when you throw a ball at the highest point where the ball is, okay, it will stop for a millisecond. Okay, so if you observe, you throw a ball in the air, at its highest point, it stops for a millisecond and then it returns back to the ground. Okay, so a lot of times a question will ask you what was the highest point of the object or what was the greatest height of the object, right? So you always have to remember or just think about the motion. If you throw a ball, it reaches its maximum height and it stops. Even for a millisecond, it stops, right? Because it's stopping for a very small second, the final speed in that instance would be 0. Okay, this is the motion we're modeling from the bottom to the top. Okay? So right at the top, because the ball stops, your final velocity is 0. So whenever a question says find the highest point or find the greatest height, you can use the fact that v is equal to 0 at that particular point. Right. Now, there's another misconception which a lot of students make. Often a question will say, find the time that an object hits the ground. Okay, so you throw something in the air, it comes down, and then it hits the ground. A lot of students think that when a ball hits the ground, the speed is 0. Now, this is not actually true, right? Because the ball is traveling at a pace. So the moment it hits the ground, it's not suddenly gonna stop. The speed will not suddenly change to 0. Usually, it will either bounce or it will take 1 or 2 seconds um, for it to come to rest or the speed to come to 0. Right. So whenever a question says or a question mentions an object hitting the ground, you cannot say that v is equal to 0. Okay, so do not model the speed as 0 when it hits the ground. Okay, because there will always be a speed when it hits the ground, and often a question will say find the speed that the object hits the ground. Okay, so don't assume just because an object has hit the ground, it suddenly the speed becomes 0. That's not true. Whenever an object collides with the ground or any surface, it will take some time to come to a stop. Okay. Right now, when it comes to objects being thrown up in the air, okay, you might have situations where the object is projected from the ground. So let's say there's a machine on the ground which is projecting a particle upwards. Okay, or you might have a situation where the question says um, Adam throws a ball from 3 meters above the ground, right? Because let's say I'm standing on ground, my hand is obviously a few centimeters or meters above the ground. So if I am throwing a ball with my hand, my initial position is somewhere above the ground. It's not on the ground, right? So you can have two types of questions. A particle is thrown up from the ground, or it's thrown up from somewhere above the ground. Now, in these type of questions, your origin is really important. Okay, so just a reminder: the origin is where you are measuring your displacement from, the S in SUAT. Okay, now let's say a ball is thrown up from A, okay, which is here. Right now, if a ball is thrown up from this point, this is 2 meters above the ground. Okay, now your displacement is going to be measured from A. It's not going to be measured from the ground, right? So let's say you throw a ball at A, okay, and the ground is 2 meters below, right? So the displacement of A from the ground would be -2. Okay, this is assuming that you've taken positive as your direction for the whole question, right? So because the ground is below A, it's going to be negative, and because the distance was 2 meters, you would put as -2, right? Now, this is really important because you will have questions where an object is thrown from somewhere here, and they will ask you to find the time it takes to get to the ground. Okay? And I'll show you in some questions, right? So, for example, let's say a particle is thrown up from O and it returns to O. Okay? In this case, your displacement is 0. Okay? The reason for that is it started from O, okay, went up and came back to the same level. Okay? Because it came back to the same level, your S is 0. Right? Your displacement hasn't changed because you threw it up from O, it came back to O. So in this type of question, you can say that S is 0. Okay? There will be other questions where, so if you look at the second example, a particle is thrown up from 3 meters above ground. Okay? So this is your ground. A particle is thrown up from here. This is where a particle is thrown up, right? And it will go up and come back to the ground. Okay. Now, your displacement is the difference between the starting point, which is your origin, okay, which is here, and your ending point, which is here. Okay. Now, what's the difference between the starting point and the ending point? Obviously, it's 3. Okay. We also need to be careful of the sign. Okay. So again, assuming that upwards is positive for the whole question, right? The start is here, okay, and the end is here. Because the ending point is below the starting point, your S will be -3. Okay, so this is again really important that you model these situations correctly. We'll get more used to this when we practice questions next. Um, And one more thing, I know this is very confusing. How do we choose the positive direction? Right now, in vertical motion, you're going up and down. So your positive direction will either be up or it will either be down for the whole question. And this is something you need to choose at the start and apply it to the whole question, right? Now, the rule that I use generally is um, look at the direction of the particle when it's first released. Okay, so if a ball is thrown up, then I would say the positive direction is up. Simple as that. Okay. Now, in this case, because you've taken positive direction as up, your your acceleration will become -10. Right? That's because gravity is acting down. Okay? There will also be situations where an object is thrown down or it's released from the top or something like that. Okay. So because the initial motion, the starting motion of the object is down, I would generally take downwards as positive. Okay. Now, in this case, your acceleration will be +10 because your positive direction for the question is downwards, and your acceleration, which is gravity, is also downwards. Okay? Yep. So as I said, if your positive direction is up, then A will be -10. If your positive direction is down, A becomes +10. Right, now let's take a few examples. So have a look at this question. Feel free to pause it if you want to and try it yourself. Right, now the first thing we always have to do is get the positive direction for the whole question, right? So an object is thrown up, right? So that immediately tells us that the object is going up from the start. So the best thing to do is take the positive direction as up. for the whole question. That's done. The second thing, we have to draw a diagram. Right, so this is your ground. The object is thrown up from the ground with speed 7. That means your starting speed is 7, right? Find the time it takes to return to the ground. So it will go up and then come back here. Okay. Now, your starting point and your ending point are both at the ground level. That means your displacement is 0, okay? Because it hasn't actually moved up or down from starting or ending point. So S is 0. We know that the acceleration in this case will be -10 because gravity is 10 and our positive direction was up. So A becomes -10. And we have to find the time. Right, so U, S, A, and T, find a SUAT formula which links all 4 of them. Right, this one will do. We substitute our values. Right, so this is what we've got. Now you can either use a quadratic formula or we can just factorize, which I will do here. So we can take T common. Okay, now when you have this situation and this is 0, then we can separate the T and the bracket. So one answer would be T equals 0. Okay, now this is obvious because when the object was thrown up from the ground, the time was 0, right? Because that's when it's thrown up. So this is the point where T is 0, and the second one we will find here. Okay, so we've done T equals 0, and the remaining bracket 7 minus 5T, we also equal that to 0. Rearrange it. So you can move minus 5T to the right, and T equals 7 divided by 5, which is 1.4. So your final answer would be 1.4, which is the time it takes to get back to the ground. Okay. Again, if you don't want to do the factorizing, you can use the quadratic formula directly. Okay, next question here. Once again, feel free to pause it and then read it yourself. Okay, or try it yourself. So Ali throws a ball. Ali throws a ball upwards, right? So once again, because the ball is going up, your positive direction for the whole question would be upwards, right? So everything going up would be positive. At 4 meters per second, now from 3 meters above the ground level. So first draw a diagram. So this is your ground, right? Now the ball is thrown upwards from 3 meters above the ground, right? So let's make a dotted line, 3 meters. Okay. So the ball is thrown up from here and it comes back to the ground. Right now, once you've drawn the diagram, you start labeling. Okay. Now, as I said, the positive direction is up, so anything up would be positive, right? The ball is thrown up at 4 meters per second. This is your starting speed. So U is equal to 4. Okay. We know that A will be -10, which is your gravity. Okay. Now S here is really important. So we started from here and it came back to the ground here, which is 3 meters. Okay. Now S can either be +3 or -3. Now this is your start. Okay, this is your end. Because your ending is below your start, right? That means your displacement is downwards. Okay. And because our positive direction is up and because our displacement is down, that becomes -3. And find the time the ball hits the ground, which is your t. Okay. So again, find a SUAT formula which links all four of these. And substitute your values. And now I will rearrange this so that it is in a quadratic form. Right, so I've moved everything to the left, so the right is 0. Once you've done that, you can use the quadratic formula. Right, this should give you two answers, which would be 1.27 . Right now, we know that time cannot be negative. You can't say minus 0.5 seconds. Time is always positive. So you cut out this answer, and your only remaining solution would be 1.27. Okay, next question here. Once again, pause it, try it yourself. Right, a ball is projected vertically upwards, so straight away we know that upwards will be our positive direction. Okay. Once you've done that, draw a diagram. So a ball is thrown from point O. So point O is here, and we know that it will return to O. Okay. Returns back to the same level. Okay. Now, it's asking you the greatest height reached by B. Okay. So for the greatest height, we are only modeling from here to here. Okay, so let's just focus on the red part for now. Okay, now it was thrown upward with speed 12. That means your initial speed is 12. We know that acceleration will be -10, which is gravity. Okay, and now remember when we did the introduction, the greatest height or the maximum height, the ball will come to a stop for a millisecond. Okay, so this is your maximum height. At this point, the ball will stop for a millisecond and then it will come down again. Okay, so if we are just modeling the red part from O to the top, then your final speed is v equals 0. Okay, because for this model, this is your ending point. Okay, we are not modeling all the way down yet. We are just modeling from the bottom to the top. So v is equal to 0. That's your final speed from bottom to top. And they are asking you to find the greatest height. Height basically means distance or displacement. Okay, so this is what we need to find. Okay. Now, find a SUAT formula that links all all four of these. Right. Once you've done that, you substitute your values. Okay, so the greatest height reached by the ball is 7.2. Right, that is your part A done. Now, just for a note, so it takes 7.2 to go here. That means going back down would also be 7.2. Okay, that's because it's starting and ending at the same level of height, right? So that's part A. And for part B, okay, part B says the total time before B returns to O. Okay. Now, for this one, we are modeling not just to the top, but all the way back to O. Okay. So once again, U is equal to 12, A is minus 10. Okay. Now, we don't have the final speed here because we are modeling back to the bottom. Okay. When it hits the ground, the speed is not going to be zero. Yep. As I said before, when it hits the ground, there will be some speed, but we don't know what it is. So we can't say the final speed is zero because hitting the ground is the final speed, which we don't know. Okay. What we can do is we can label S, right? It's starting at O and coming back to O. Because the the level is the same, your displacement is zero because it hasn't moved up and down between start and end. Okay, so S is zero, and they are asking you to calculate time. Right, so find a formula which links all four of these. S equals ut plus half at square. Right, then substitute your values. So 0 equals 12t. Right, now half a means half of minus 10, which is minus 5. So I will just do that directly. And now from here, you can either use the quadratic formula or factorize it. Okay, so one answer would be t equals 0, which we're not going to use because t equals 0 means when it starts traveling, it's at O, which we already know. And the second answer, you take the second bracket, equal it to 0, then rearrange it. You should get t equals 12 over 5, which is 2.4. Okay. Again, you don't have to factorize. You can just use the quadratic formula. Great. Next question. So again, you can try and pause it and try it yourself. Um, so a book falls off the top of a bookcase. Right. So this is a slightly different one. The object is falling down now, right? So we will take down as positive. Okay. Now look at the keyword. It says falls, right? That means it's just been left or released. We haven't actually thrown it down. Okay. So if something is just released on its own, the starting speed is 0. right? Because it just fell off. Nobody pushed it down. Um, the shelf is 1.4 meters above a wooden floor. Right, so let's draw a diagram. So this is your floor. And 1.4 meters. Okay. The book was dropped from here and it reaches the floor. Okay. Right now, downwards is positive because it's falling down. Okay. Now, this is your start. This is your end. Okay. Now, the 1.4 meters is the end is obviously below the start, right? So your displacement is below, but because we've taken downwards as positive and also because your displacement is down, that means S is equal to 1.4. Both of them are in the downwards direction. That means positive. What else do we have? We have obviously acceleration. Okay. Now, acceleration in this case will be 10. It will not be negative 10. The reason is we've taken downwards as positive, right? Because the book is falling down. So downwards is positive. We know that gravity is also downwards. That means both are down, which means positive. So A will be positive 10. And what else do we have here? We had U is equal to 0, right? Because the book has just fallen. We haven't thrown it or anything. So we've got these three. And firstly, they're asking you, or if false means U is 0, the time the book takes to reach the floor. So time equals question mark. So find a SUAT formula which connects all four of these. Right, substitute your values. Now remember U is 0, so 0 times T will just be 0. Okay. And then half AT square means half times A. So half times 10 is 5 T square. Okay, I'll write the whole thing for you just in case. Okay. So 0 times T is 0, so that just goes away. And half times 10 will be 5. Okay, so T square is equal to 1.4 over 5. And then you do square root. And that should give you 0.529. Right, so that's part A. Part B says the speed with which um, the book strikes the floor. Okay, so again, we're going to model from start to end, the same model as we used before. This time we need to find V. Okay, V is the final speed. So if you take this model from start to end, V will be the speed when it hits the floor, which is basically what they are asking you in the question. So this was part A, and here we will do part B. Now they don't want, we've got T, we need to find V. Okay. Now we can use the T again in the same model if we want. I will prefer not to use it, but yeah, if you want, you can use T as well because we found out T now. Yeah. Okay. So I've got these four and formula connecting all of these. V square equals U square plus 2AS. So V square equals 0 square. V square is 28, and then V will be square root of 28, and that will be your answer. Let's try this question here. So a ball is thrown vertically upwards, which means upwards is positive. Okay, then we will draw a diagram. It doesn't say whether it's thrown from the ground or above the ground, but it says here, find the height above the ground from which the ball was thrown, right? So obviously it's not thrown from the ground, it's thrown from somewhere above. Yep. So this is what we need to find now. This is your start, and this is your end. We've taken up as positive. That means your displacement, which is S, will be negative, okay, because your ending point is below the starting point, which is down. Okay, so S will be negative. The problem is we don't know what S is. So S will just be question mark for now. Right? So let's look at what we do have. Again, we are modeling the whole journey from start to end. Right? So we know that U is 21 in the question. T is 4.5. A will be negative 10. And we need to find S. Okay, once you've got this, you can use your calculator. Right, so we've got S, which is negative 6.75. As I told you before, it will be negative because your displacement is down, because the ending point is down and your positive direction was up. Okay, so S is negative 6.75. The question is saying find the height. Okay, so the height will just be 6.75 meters. Okay, they're not asking for the displacement, they're asking for the height, and height is always positive. Okay, so that's done. And yep, I think that should be enough for this lesson. Make sure you try the worksheet that I've attached in the description, and we'll see you next lesson. Good luck.